Okay, welcome everyone. So for this installment of our Like a Robot Workshop invited talks, we've got uh, Xingxing Wang from Unitree Robotics. Xingxing, during his master's degree at the Shanghai University back in between 2013 and 2016, he independently developed a low-cost quadruped robot called XDog with the purpose of building low-cost, reliable quadruped robots. And after graduating in 2016, he briefly joined DJI, and afterwards in August 2016, he founded Unitree Robotics, and he's currently the founder and CEO at Unitree Robotics, and he currently has more than 60 patents. And it's our pleasure to have Xingxing speaking today. So over to you, Xingxing.
可以开始。
好，
自我介绍一下。
My name is Wang Xingxing, is the founder of the Unitree Robotics. I start. Our company is wanted to let more people to enjoy the quad robot. This is our company's building, and the technology tree of the hardware, such as the PC, mobile phone, and the 2010 drone, and the 2020 maybe is a quad robot. It is we believe. And our history is that our company is started at the our company started at the build 2030. I built a low cost and high performance quad robot XDog during my graduate student. The XDog was released in the 2015. Use low cost and high performance auto-rotor BLDC motor. Our company is the first robot is the Leica Go robot, use the direct force control, and here two robot is our new robot. Is the bigger one is the A-Lingo, the small one is the AE robot. The new we use the increase the reduce life and the significantly, and the all cables and the cooling system are placed internal, and which makes the robot pretty and reliable. More sensors including the multi vision systems and more powerful control CPU and more friendly user interface. Here is a small older videos. And our other videos, let me show it in a moment. This is also is the other. So wait a moment. OK， 看不了吗？开始。可以。This is also is the other video. But it is the 90 years. This is a position recognition. Also, this robot is like a robot. Is our older robot.现在这个还在吗？算了。我回到那个。OK，this is our new robot. Is AE is writer and the writer and high reliable and the maintainable and built in the RGBD camera and the personal tracking and the real-time video transmission and the operational model modules such as the radar, GPU, such as the tier 2, and the variables user interface. And each leg has the 4 sensor at the foot. A user can and about 1 hour battery life and about 1 hour charge time. And you can use the joystick with the smartphone. This is you can see this is a smartphone control. Here our new video is shows let me show is about A1. A1 is very fast and more stable, and the cost is very low. This video you can also find in the YouTube. Let me show. This is our new website. Is let me show it. Wait a moment. I open the website. Our website, new website. Yeah, this is our new website. You can see the product and such as the battery, age, motor, and the robot. And if you join in it, you can see this 3D model in the A-Lingo robot. Also have the AE robot and the Leica robot. You can use the left side, the battery button to control the robot, such as the pitch. This is roll and forward control. and back forward, left and right. You can play in our website, unitree.com, uni.com. The core decisions such as the angle joint, the high performance angle joint, have the long life, and the here is we use the auto rotor motor and the decrease the roll cost, and the autopod shaft have the torque limiter to protect the grill, and then increase the grill life. Both the autopod shaft and the motor have magnetic encoders, and we use the whole shaft to be cables so the cables and the other shaft can go through. Here is the other picture, and this is a row. Here is the torque limiter. Here is the spring, and the whole. This is a whole shaft. You can cable the other wiring to throw it, and it is also low cost, and have the whole low cost the output encoder and the low cost motor encoder inside. Here is the motor encoder, and here in this side have the output encoder. Here is the other picture. You can see combine the far and the knee joint in at the same size. Here is the you can see that this is the knee motor, and this is the phi motor and the reduce. This is the other reduce inside, and this is a decision. You can see that this two motor is together, and the PCB motor driven board is also is together is in this side, and so that there is no external cable, and they also have the torque limit, and they have the 360 degrees rotation of the phi joint, and able to bear a large external impact force. Each joint has the input and the output encoder. Here is the body. This body is so simple, and the high right weight and high structures and strong, and the high regulated, and have very few parts and easy to model and the low cost manufacturings, easy assemble and maintenance, and low assemble difficulty and low man hours, and pretty and beautiful. And here is other pictures. You can find he has two have the upper shore and the low shore. This is the upper shore. This is the low shore, and the gate combined to the main structures. This is the battery, and this is the power board. This is power board, and this is sensor CPU, and this is a motion CPU. This is the cables, and this side is the motor. Here is the joint. His joint is also low cost, and he has the 15 encoder, bit encoder, and has the temperature sensor, and is also, and if need, this joint can also use the whole shaft. You can see this is a hollow shaft. Here is the AE is the cooling fan. Here is the cooling fan. You can see this side. This is a cooling fan, and this is air in. This is the air in, and this is the air out. This is cooling fan. This is the power and the control structure of the A-lingo and the AE. You can use the import power and have also can output the power. So users can add external sensors and add external computers. Also, the border control has the IMU and use the internet to connect with the sensor CPU and the motion control CPU. Also can connect with the user's personal PC. And can use the USB to connect real such as the real sensor or other radar and other sensors. This is A-lingo has the motor sensor. This is a VSLAM. This is use the vision sensor to can be used for the human-robot interaction, pose recognition, target recognition, and the tracking. This is use to radar to mapping and the abstract to end abstract. This 3D radar. And now some people researchers think that quadruped hardware and control are also close to the perfect, but actually there are still many problems do not well solved. We still need more hardware innovation to improve the movement performance, reliable, and the decrease the cost. We still need a new control that is suitable for wide range of the usage. Consider the hardware, the electronic quadruped developed pretty fast in recent years. One main reason is the development of the motor joint hardware, such as the planetal reducer with the low reduction rate and the low cost, but it also has those disadvantages. The gears with high structure and the accelerants also have a little expensive. The cheaper gears have a bigger gap and between teeth. The noise of the reduce increase with the increase of the reduce gap. The noise is very large. And we also solving this problem, 3 problems now. Our new decision is under testing and the participation. Our customers did some development of our robot. This is like our robot is used by the Google research. Animal learning the locomotion from the animals. Here is the other customers. Is the South University of the Science and Technology, China. They use the radar to tracking on the person. Feature has come, just waiting to be popular. That's all. Thanks.
Thank you very much, Xingxing. That was an impressive talk. So for our participants on Zoom, please feel free to ask any questions on chat, and we will convey the questions to Xingxing. In the meantime, Xingxing, I have a couple of quick questions. Something that we face with when we are designing our robots is always trying to do thermal management of the joints. It's impressive that you have a fan embedded into your motor assembly. Is that sufficient? Are you how else are you managing overheating of the motors? Do you have any heat sinking? Do you have that problem?
对，就是跟电子生物社和他们的热管理系统怎么样，我们要画个多热。
我们目前的那个机器人都使
老
用了先进。等一下，我把它提。就你是有翻译的。我们目前的机器人都使用先进的。
We are getting a few more questions on chat.
Okay. Let me help Xingxing to translate his answer.
Okay.
Xingxing just says, now our reducer has a high reducer ratio, so now the overheat problem is not serious. And also, you see, we placed a fan inside of our joint, so most time our motor does not face overheat problems. And also, as for the A1, the smaller robot, most time because its weight is lighter, so most time its joint does not overheat. So that's our solution for the overheat problem.
Okay, thank you very much. I will ask the questions that are on the chat. So one question is, you mentioned a sensor at the foot on the latest version. Can you expand more on what data it provides? Is it just contact switch or does it provide force?
这个关于足部的那个传感器，咱们是就是想说详细一点，咱们这个是只提供它的接触还是非接触，还是说能提供这个大小？
目前是直接用的一维的传感器，就是提供的话是有一个维度的，就是其实是个线性的，但是线性度并不是特别好，因为我们现在用的传感器，就是不同的版本它有一些差异，但都是一维的，不是说不是一个开关。
Okay, let me help Xingxing to translate. Xingxing says now our force sensor on the foot is just a one-dimensional sensor. So it's not a switch. It can tell you the force, the scale of force on the foot. And now, because it's just one-dimensional, so it cannot give you the direction. It's just the scale of our force on the foot.
Okay, thank you. We got two more questions from Dennis. Can you talk more about the control challenges for the quadruped? In what cases do you think we need a better controller?
那么在什么情况下我们需要一个更好的控制器？就目前咱们在哪种控制状况下，我们觉得咱们控制器做的不够好？
是这样的，就是目前四足机器人在平地呀、行走、跑步，其实大家目前的话就是说我们或者别人其实都解决比较好，但是一些复杂的一些，比如说楼梯，一些比较恶劣的，比如说泥地呀、或者一些石块这块，目前的控制器的话，其实是适应面还是比较窄，就是它很容易摔倒啊。
Now our robot and also robots in other companies performs pretty well on the flat floor, but now the main challenge is just for stairs and also rough floor, for example, a road with many big stones or just the earth road. So at this situation, our robot cannot perform satisfactorily. And that's a main challenge for our next development.
Okay, thank you. And there's a follow-on question from Dennis. Do you consider adding an arm on top of the dog?
咱们有没有考虑在机器人上装 GCD？
是在考虑，我们其实是至少从去年开始就在考虑做这块事情，不过目前市面上没有比较合适的机械臂，所以说目前还没有做上。
We start concern this idea about last year, but now the main problem is that on the market, we have not found a suitable arm because we need a suitable arm for our robot. So now we're still waiting for a good arm to put on it. So we have not do some practical work on adding an arm on the robot.
I see. Thank you. And for those who might be watching our live YouTube stream, please feel free to ask any questions on the YouTube chat. I can then ask the questions from Xingxing. I have another question. I think you might have answered it. So is it correct that you are also separately selling the actuators? Are you selling the motors as well?
Sorry?
Are you separately selling the motors or as well, the motors used on your robot? Can one purchase the motors separately?
目前 A1是销售的，但是目前可能量比较小一点，就那个可以零售，但是可能目前供货不是特别多，我们主要出售整机了。
Hello. Now we also sell our motors. You can buy it separately, especially for the A1 robot. Yeah, you can buy the motor of A1. But the problem is that now we focus on selling our robot. So if you wish to buy the motor, maybe you have to wait a long time before you receive it.
Okay. Okay. We got another question. Aaron Zhang. Could you provide more details about your control structure? Are you using model predictive control?
他们想多了解一些他们的控制方面的，因为咱们有没有用 MPC？
目前我们也用 MPC 了，当然我们也用原本的控器。
Hello. Now we are also using the MPC controller, and we still use our traditional controller. Now we combine these two controllers. So yeah, we're starting to use MPC controller. It performs pretty good, but we have not. We still use our traditional controller on some robots.
Oh, okay. Okay, thanks. Dimitri, Aaron, do you guys have any questions?
I'm good, thank you. I'm mostly covered, thanks.
Yeah, I'm good as well. But very impressive work on this quadruped. Nice job.
And I really like the website where you could control the robot on the web interface itself. What sort of control interface do you have? A ROS API? Can I use a robot operating system to control the robot? And does it also come with a gazebo-based simulation?
目前是有部分支持的，不过还没有完全落地。
Yeah, now you can find our API on our official GitHub account. We support the ROS control and also the gazebo simulation, but some part has not been finished. Anyway, you can still do some fundamental function by our given API now. Now some of our customers are using ROS to control their robots.
Okay, so there are a couple of questions in the chat related to the question that I asked. So Nathan is saying the current interface is with ROS 1. Is there a plan to eventually support ROS 2?
No, it does not have that plan. Now we are trying to make our ROS 1 interface runs better.
Okay. And another question, do you consider providing your controller in simulation as a like as a shared library?
那么咱有没有打算把咱们的控制器，然后就是做成 SO 元件放到咱们房间里？
这部分的话，就是工作量有点大，暂时没有计划，可能后期可能会，就是或者可能过段时间弄个简单的完整的。
Now we have not started work on that because we think that's a little tedious to finish such work. But maybe we will do it in the future. We will make a simple edition of our controller so that everyone can use it in their simulation.
Okay, thank you.
Is your quick follow-up on that? Is your controller documented, both the classical one and the new one you're using? Documented in a paper, online?
论文是没有，是因为那个公司里头其实就没有讨论。然后文档的话就使用那个直接使用的。
Sorry, until now, we does not have paper to publish our traditional controller because after we establish our company, we does not publish paper. But we have the document to introduce how to use our controller. But as for the algorithm, we have not published it.
Can you give some more, are you willing to give some additional details on your traditional controller?
多了一点细节关于老控制器。
最老的控制器的话，直接就是用的就是直接力控嘛，就是怎么说呢，也是把机身当做简单的钢琴，然后直接算主张力，就是把它分为支撑图的力，直接用解析法就算的算主张力，也是讲的钢琴，然后把图关联忽略了。但是实际用的时候会加一个简化的模型的腿的关联不长。
Now our traditional controller, we also simplify the whole robot as a rigid body, the rigid body of its main body. And then we calculate the desired force of every leg. Then we use our motor to achieve it. That's our main algorithm. And also we have an algorithm to consider the inertia of every leg so that we can make sure our leg can generate exact force on the foot. That's the main structure.
I see. Interesting. So it's a contact force-based control, inverse, sure. And sort of inverse dynamics based from there.
Yes.
Good. Nice. Thank you.
A slightly less technical question from me. Given the current COVID situation, has that impacted your company or your production, or is everything back to normal now?
Oh, sorry, you mean back to normal?
Yes. Now, are you back in full production? Are you guys back at work? Has that delayed any of your plans?
咱们的长期的这个产品上的打算是？
我们目前有2个打算吧，就是一个是出非常实用性的，就是跟波动力有点类似的这样，还有一款就是我们希望机器人是能。就是更加便宜，然后应用性更好，就是有点像慢慢讲究生活吧。
Hello. Now our product plan is that we wish to have 2 product plans. The first one is just like the Boston Dynamic. We wish our robot can face to the application, so that the company or research institutes, they can use it to do some development to achieve some useful usage. And the another line is that we wish to make the robot even cheaper. so that everyone can buy one to use it as a core play, just as a drone. That's our two future product lines.
Okay, thank you. Before we thank our speakers, are there any final questions on the chat? On YouTube, of course, there was a comment saying, "Can the robot do a backflip?" I don't know whether
Sure.
that's part. Okay.
So that's very impressive.
And if that's all the questions, I'd like to again thank Xingxing and Unitree Robotics for the talk. It was very impressive and very informative. And thank you again.
Thank you.
Thank you.
Thank you.
Okay.
Thank you, Xingxing.
Bye bye.